Hello everyone. Today let's solve the problem number 115, distinct subsequences. So what the question states here, we are given two strings s and t. You can clearly see here we are given two strings s and t, and we need to find the number of distinct subsequences of s that is equal to t. So number of distinct subsequences of uh, s that is equal t means we have to make a rabbit out of this one, a rabbit itself. But here we have been given triple B, right? Here we have to make this one double B rabbit out of triple B rabbit, this one here. So they have clearly mentioned in the this one explanation that there are three ways. You can clearly see here, by ignoring this B, by ignoring first B, or by ignoring second B. By ignoring third B, by ignoring first B, and by ignoring second B, you can make this rabbit T out of S, right? So that's what they have given in the question. So same goes with example 2 as well. You have to make bag out of this word, right? You have to make T out of S, means bag out of this one. So here they have clearly shown the one in silver and the one in white. The one in silver as this one we have to ignore. So here B, A, G is ignored. This is one way. Same goes with second way, third way, fourth way, and fifth way. You can just look into it. There are 5 ways that we need to return as output. So here, how many ways are there? There are 5 ways we can generate back from S, right? Or T from S. So there are 5 ways to generate T from S or back from S. So we need to return that 5 in this case. So I hope the example 1 and example 2 is completely clear along with the question, right? They have explained wonderfully. So here I think the question, what we need to do is completely clear. So initially let's discuss the approach step by step, followed by edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. So initially, as usual, let's discuss the approach. So let's discuss the approach step by step here. The same example, the first example that they have given in the question, I have considered the same here. The first thing that we need to consider here is we are going with the 2D DP, right? So we are going with 2D dynamic programming. So just keep this in mind. So the first question they have clearly mentioned, there are 3 ways to generate rabbit from S, right? By ignoring this B, by ignoring this B, and by ignoring this B, we can generate the rabbit in 3 ways. Means we have to generate T out of S, right? So that's what, in 3 ways. So let's see this one step by step, right? So here the first step is initialization part. The first step we will define DP state, right? Nothing but we are going with 2D DP. We have discussed this one. We are going with 2D DP, nothing but DP of ij. So here in this case, so M will be length of T. So here this one, let's consider this one, length of T. This will be M basically. This will be 6, right? 1, 2, 3, 4, 5, 6. Length we are considering. M will be 6 in this case. And this is length of S will be, we'll considering N. This will be 7. One extra B we have, right? So this one 1, 2, 3, 4, 5, 6, 7. In this case, M will be 6 and N will be 7. So this is table dimensions, right? So first we will define DP state. So I hope this is clear. So the next step here is we have to initialize the base case. In this case, base case, let me write it here itself. DP of 0 J is always 1 for J. Why? Because this means an empty T can be always formed in one way by deleting all the characters in S. Suppose suppose we don't have anything, we have empty string, then we can delete all the characters and form the S, right? Form T out of S. So that's what we can do always, right? This is for the empty string, right? This is for the empty string condition. So this is the base case that we are going with. So DP table after the initialization would be DP of 0 J would be 1 here in this case. So let's go with the first row. We are filling 1 here. This is for the empty string. Again I am telling. So this we are filling with 1. I hope this is clear. So every other cell will be initialized with 0 here in this case. This is the step 1. So let me write this one quickly. So this one 7 into 6 we are going, right? So S is nothing but 7, T is 6 for this example, right? So we know this. So let me initialize this one with 0. Give me a second. Yeah. So here in this case we are going with 8 columns and 7 rows. Why we are going with 8 columns and 7 rows? Here this one we have m equals 6 and n equals 7, right? We have to go with 7 columns and 6 rows, but we are going with 7 rows and 8 columns. We are going with here uh, m plus 1 and n plus 1 for easy computation for the array. M plus 1 and n plus 1. Just remember this one means here 8 columns and 7 rows plus 1 we are giving, right? So here this is fine. So let's go with the step 2 here. We have to fill the DP table using the transition formula. If just remember this one, if s of j minus 1 equals t of I minus 1, then what we will do, we will go with this formula, right? Dp of ij equals dp of I into j minus 1 plus dp of I minus 1 into j minus 1. Otherwise what we'll do, we'll go with this formula, dp of ij equals dp of I j minus 1, right? Just keep this in mind. We'll do this one step by step for every row. We have already filled for the base case first row. Let's start from the second row, right? Let's do this one quickly. In this case, we know the formula now. So let's fill the DP table row by row. We are processing for row. So here we are processing row 1 and row 2. So you can just consider row 1 and row 2 differently. So just for the example sake, I'll just consider row 1 and 2 at the same time, right? So here first what we will do, only s of 0 here, this one only s of 0 equals r means matches t of 0 here, means dp of 1 comma 1 is updated here. So just give me a second here. So here again I'm telling we are considering when row equals 1, right? So s of 0 is r here. You can clearly see s of 0 means first letter s of 0 is r, that matches t of 0, right? That matches t of 0. So t is also ra but triple b it, right? S of 0 here is r, matches t of 0. So only dp of 1 comma 1 is updated here. This one will be 1 from this one, right? I hope this is clear. From dp of 1 comma 1 to 1 comma 7. So this was already one initialization step for the empty string, if you noticed, right? So this will be 1 comma 0 will be 0. In this case every cell will be 0. Let's fill this one very quickly with 0, right? So just give me a second here. So this is for r equals row equals 1, when row equals 1. So here let me do one thing. Let's consider row 2 also here itself. So I have considered for row 1 and 2 right here. Let's consider row 2 also here itself. So now we are considering for row 2 nothing but dp of 2 comma 2 gets updated, means s of 1 equals a here. You can clearly see we have already done for r. We'll go with a. S of 1 equals a, that matches t of 1 equals a as well, right? So here dp of 2 comma 2 gets updated, right? From 2 comma 2 means here this one. These are the cells that has to be filled with 1, right? So let me erase this one quickly and make this one 1 instead of 0, as we are going with row 1 and 2 in the same this one, right? Same grid or same dp table here. This one, let me give here 1 1. I hope this is clear. This one dp of 2 comma 1 will be 0, sorry. From dp of 2 comma 2 we are updating, right? This will be 1 1 1. I hope this is completely clear. This is for the ra. Here second row ra matches, here this one r matches, right? So next let's go with the this one row 3. Now t equals rab we have to consider. T equals rab we are considering, right? This one will be ra, sorry, this one will be RA, this one will be R, this one will be empty string, this one will be RAB in this case, right? We are considering RAB. Just give me a second here. So yeah, so here initially let's fill all the cells that are already filled. So I'll just give here 0 1 1 1 1 1 1 here. This was 1 1 1 1 1. So in this case, RAB can be formed in multiple ways from S, right? Either DP of 3 comma 3 or DP of 3 comma 4 and DP of 3 comma 5. DP of 3 comma 3, 3 comma 4, 3 comma 5. We have 3 B's. If you see that one, we have 3 B's. Here I'll come. So here you can clearly see we have 3 B's over here in the T. We are considering RAB. We have 3 ways, right? So we have multiple ways. RAB can be formed in multiple ways from S. DP of 3 comma 3, DP of 3 comma 4, yeah, DP of 3 comma 4 and DP of 3 comma 5 are updated. S of 2 is B, we know that one, and S of 3 is also B, and S of 4 is also B. Here we have 3 different ways, right, to match T of 2, nothing but B here. In this case, we will go with 0. This one will be 0. 3 of 2 will be 0 as well here. From 3 comma 3 we are considering, right? So this will be 2, 3, 4, 4 and 4, right? RAB can be formed in multiple ways from S. So that is the reason we are updating in this way. All other cells will be 0, right? We are processing row 3 actually here. So just give me a second here. We have processed row 1 here. This one in this case, yeah, we are processing row 3, 0, 1, 2, 3, right? So the next step here is we are going to process row 4. Nothing but we have to go with, in this case, we have to process RAB here, right? RAB this can be formed in 6 ways. So DP of 4 comma 4 and DP of 4 comma 5 is updated here. This will remain same here, empty string 1 1 1 1 1. So let's write this one quickly, as we have filled this one already, right? So let's write this one quickly. So this is 2 2, and if I remember, so this will be 2 3 4 4, right? Sorry, 2 3. So just give me a second here, I got confused here. Yeah, 2 3 4 4. So this one will be one more 0 here. We are starting from, so yeah. So this has to be 0 itself. 2 3 4 4. In this case, this is for empty string, this is for R, this is for RA, and this is for RAB, and this is for RABB, right? So in this case, what we will do, we are processing row 4, right? So here RABB can be formed in 6 ways. So how can we write that one? Initially, we will update the DP table here. This one, what we will update, DP of 4 comma 4 and 4 comma 5 is updated here. So I can write in this way, 0 0 0 0 3 666. In this case, DP can be updated in 6 ways, right? That is the reason I'm giving here 0 0 0 0 0 3 666, right? So next, let's process 5 here, row 5, right? So this will be row 5. In this case, this will be empty string, this will be RA, this will be RAB, this will be so just give me a second, did I get confused here? Oh, this has to be R only, so just give me a second here, I got confused here. So just give me a second here. Yeah, this has to be here What happened to this one? So yeah, here this one, let me give 6 comma 6, 6 comma 7. This is fine. So this we are considering for rabbit. We are considering for t equals rabbi in this case for the row 5. This will be empty string. This will be r. This will be ra. This will be rab. This one will be rabb. This one will be rabbi, right? So finally this will be rabb bbit. So we are going for this one rabbi in this for this particular row. Initially this one will be 1. This is fine. This one will be 0 1. This is also fine. This one will be 0 0 1. This is fine. This one will be 0. We started from this one 2 3 triple 4. This is fine. From previous one what we filled, let's see this one. Just give me a second. 3 triple 6, right? So here let me give 3 triple 6. All other will be filled with 0. We are processing row 5 now, so we are going with rabbi this time, right? Rabbi can be formed in 6 ways as well. So here dp of 5 6 will be updated. Dp of 5 comma 6 will be updated. Rabbi can be formed in 6 ways: 5 comma 5 and 5 comma 5 comma here 5 comma 6 is updated in this case. So here this one 6 5 comma 6 and 5 comma 7 will be this one 6. All other will be 0. This will be 0 as well. So 5 comma 5 will be 0 as well. So here let me give 0 in this case quickly. So the final step here, let's process the last row here. Let me write here. So sorry, this one has to be 1. This is fine. This one has to be 1 as well. This is fine. This one is 0. So just give me a second. So I forgot. Just give me a second here. This one will be 0 0. This is fine. This is 2 3 4 4 4 and 3 triple 6. This is fine as well. The fifth one, the previous one was last 6 6, right? dp of 5 comma 6 we updated, so this one has to be 6 6 here. After 5 comma 6 5 comma 5 5 comma 6 it will be 6 itself. For 5 comma 7 also it will be 6 itself. So the final row here we are processing. So there are 3 different ways here. So 3 different ways of rabbit. This one we are considering. So what happened to this one? Just give me a second here. Yeah, we are considering for rabbit this time, right? T we are considering for rabbit. So this will be empty string. This will be r itself, not ra. This will be ra. This will be rab. This will be rabb. This will be rabbi, and the final one here will be this will be rabbit. So there are 3 ways. In the last cell there are 3 ways. We are going with 6 comma 7 3. All other cells will be 0 in this case. So here the last cell, the value whatever found in last cell, we will return this one as output. So in this case we have got 3. So the final output here will be dp of 6 comma 7 in this case. dp of 6 comma 7 is 3 in this case, right? Meaning there are 3 distinct subsequences forming rabbit. This one here, rabbit from ra triple bit rabbit. So we can form this one rabbit from rabbit in 3 3 distinct subsequences. So dp of 6 comma 7, the last value in the cell, while we processed row 6. I hope this is completely clear. We went step by step, so every dp table, right? I hope this is completely clear. So let's this was the this is the approach that we'll be going with, right? So I hope this is completely clear. Next, what we will do, let's discuss the edge cases one by one. So after discussing the edge cases, let's start writing the code, right? So before that, let's discuss the edge cases here. So here the first edge case is for t is larger than s. So input abc, t is larger here, abcd. So the output will be 0 in this case. Why the output here is 0? Because it is impossible to form t from s, right here in this case. So this is 0. So the second edge case, we are going with here as this one, t is empty, s equals anything we have given, t empty string. Here this will be t is nothing but empty string here. This is fine. T is empty string. Output will be 1 in this case. Only one way, by deleting all the characters. So whenever we have empty string for t, if we delete this one entirely, so we can match up. Same thing, right? We can match this up. So that is only one way, right? So that's what the output here is. So the third edge case we are going with here is s and t are the same. S equals abc and t equals abc. We have the output here. We have is this one, 1. The output here we have is 1. Only one way is to take the only way is to take s as it is, right? So s as it is means s abc, t is also abc. So there is only one way, right? And this so output will be 1 in this case. So fourth edge case we are going with here is s contains repeated characters. S double a we have only double a in t, right? So there are 6 ways. So you can just write out in the same way if you want to know, right? I am just writing the output directly with by giving explanation. I have tried it out. You can just write out. So that will be lengthier. You have to consider every row. You have to process every row step by step as I have shown, right? So you will get to know output how we got 6 as output. So in this case here it will be 6 because there are multiple ways to pick 2 A's, right? So there are 6 ways here to pick 2 A's. So the final edge case here is large s and t. So we are going with 1000 and 1000. Output, I'll just write it as here desired output that we need to get. We must use optimized DP solution. Optimized DP solution for this. So we have to make sure that this works for this input as well, right? So the length of the s and length of the t is 1000 here, means huge, right? In this case, so we have to make sure that this works properly as well, right? These are the 5 edge cases that we need to keep in mind. First edge case is for t is longer than s. Second edge case is for t is empty. The third edge case is for s and t are same. The fourth edge case is c contains repeated characters. S contains repeated characters. Got confused here. Fifth edge case is for large s and t. I hope all the edge cases are clear. Now let's start writing. Let's start writing the code. Initially, what we'll do here, if t is longer than s, then we cannot form t out of s, right? So this we have already discussed multiple times. So simple if condition here, if this one, if length of the s is less than the length of the t here, then we will directly return 0 because we cannot form t out of s here. So we have already discussed this one multiple times, and we will next step we will swap s and t for the efficiency, just for the sake of efficiency. So we will make sure that m is less than or equal to n, or rows is less than or equal to column here. So let's just swap this one quickly. S comma t equals t comma s. This is fine. So the next step here is let's go with m and n. Let's initialize m with length of the s. We'll be making use of length of s and length of t many times. So let's assign this one to the variables instead. So we can use m and n, right, within the code. So this one will be length of the t. I hope this is clear. So let's create the dp table now. This one will be dp equals array of n plus 1, sorry, not n plus 1, this will be m plus 1 dot fill of this one map. So this is fine. This will be array of n plus 1. Let's fill this one with 0 initially. So here we can clearly see we are going with a 2D DP table of size m plus 1 and n plus 1, rows plus 1 and columns plus 1. So we have discussed this one. We are just making use of m plus 1 and n plus 1 for the this one easy computation. Here it was 7 and 6. Instead we went with 8 columns and this one 6 rows, I mean 7 rows, right? M plus 1 and n plus 1. At that time itself I had explained we'll be making use of the array of size m plus 1 and n plus 1 as we are going with the 2DDP, right? So I hope this is completely clear. Next step is base case. Base case, what was the base case? We can form any empty t, right, by deleting all the characters in the s. So we can form any empty an empty t. So for that one I'll quickly make use of the for loop here. For let j equals 0, j less than or equal to n, and here j plus plus. We are incrementing j in this case. So this will be dp of 0 j. This will be 1. I hope this is clear. So the next step here is we have to loop over t and we have to loop over s as well, as we are going with the 2DDP. So let's loop over t and s, means we are going with 2 for loops here. So let here I equals 1, I less than or equals to m. Let's increment the I plus plus. For let j equals 1, j less than or equal to n. Let's increment the j here. This is fine. So if characters match, then we will add both the possibilities, right? Include or exclude. So I showed 2 formulas before processing from row 1 to row 6. After the initialization, I showed 2 formulas. One thing is if the characters match, then we are adding the possibilities either include or exclude, right? So that formula will be same thing. We'll be articulating that one in the form of code. Right here we'll be making use of the ternary operator here. So I'll just go with here dp of I j equals dp of I into j minus 1 here. This is fine, plus s of I minus 1. This is equals t of j minus 1. This is fine. If this exists, so then what we have to do here, this is fine. dp of I minus 1 into j minus 1. This is fine, or else 0. So include or exclude we are writing for. This is the formula. This is fine, right? So next thing, I think we have to keep this in mind basically. So it's just kind of a formula. So within the for loops, right? So this is fine. The final thing is we know this, we have to return the final count, nothing but dp of mn, right? So we will return, this is simple, dp of m and n here. This is fine. Let me format the code once and let me hit a run button here. So here you can clearly see the sample test cases are getting passed here, right? So let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed here, right? So the code works absolutely perfect here. So let's quickly discuss the complexities of for the code that we have written. So the approach that we went with here is 2D dynamic programming, that we know, right? So the approach that we went with here is 2DDP, and the time complexity here would be the time complexity would be big of m into n. Just give me a second here. This will be m into n. Why the time complexity here is big of m into n? Because we are filling an m into n dp table, and the space complexity would be here big of m into n as well. Why the space complexity here is because of m into n? Because we are storing an m into n dp table, right? So that is the reason the time complexity and the space complexity of the code that we have written is big of m into n, right? I hope the solution or the code that we have written is completely clear. We have clearly written this one step by step. I have explained this one in the approach as well. So I hope this is completely clear. For now, this is it. Thanks for watching, guys.